Okay, so in number 11, it's a weather balloon that's floating at a constant height. So because it's floating at a constant height, VI is 0. And it says the packet hits the ground, so it's giving us a velocity of negative 73.5 meters per second. And of course this negative just means it's going down. And A is 9.81 meters per second squared. It's also going down. And the first part of the question wants to know how far does it fall. You're looking for delta D. Now, even though the question puts the negative on the 73, you could call down positive. But so I don't screw you up, I'll call down negative. VI, VF, A, delta D, so VF squared is equal to VI squared plus 2A delta D. The VI goes to 0, and you're solving for delta D, so divide by 2A. So VF, negative 73.5 meters per second, and that gets squared over 2 times, and of course if you're calling down negative, then the 9.81 has to go in as negative as well. So don't forget to square the 73.5 divided by negative 19.62, and you get negative 275.344 meters, where of course this means down. Okay, part B wants to know how long did it take, delta T. So if you're given a VF, a VI, and an A, and you're looking for a delta T, I would just go back to our grade 10 equation, A equals VF minus VI over delta T. VI goes to 0, delta T comes up, A goes down, negative 73.5 meters per second divided by negative 9.81 meters per second squared. And you get a delta T of 7.4924 seconds. Works out to be positive, which is a good thing since it's time. Number 12. Number 12, you have a tennis ball. Okay, and you're dropping it. So it's falling down. Delta D is 1.2 meters down. A, of course, is 9.81 meters per second squared, also down. And if you're dropping it, the VI is 0. After it hits the ground, it bounces back up, but not as high. So the delta D here is just 1 meter, and it's up. A is still 9.81 meters per second squared, down, and it's going to go up until it stops. Okay, so the first part of the question wants to know with what speed does it get to the ground. So the instant before it hits the ground, what's the speed? So don't say 0, it's not going to stop. If it stops, everybody would want me to be dropping them off the roof of the building. It only stops after it hits the ground. Okay, so the instant before it hits the ground, we want the VF. So we have the VI, we have the A, we have the delta D. So in part A, we would use VF squared is equal to VI squared plus 2A delta D. VI is 0. So VF squared is equal to 2. And if you want, you could call down positive or negative on this first side because it's all going down. So since it's all going down, I'll just leave them as positives. But if you wanted to do negative, they'd both be negative and they would end up at the same answer. So 2.4 times 9.81, take the square root, 4.8522 meters per second, and that's down. Now part B wants to know with what speed does it leave the ground as it goes to bounce back up. So we have the same given, so we should use the same equation. VF squared is equal to VI squared plus 2A delta D. This time it's the VF that goes to 0. Rearrange for VI, so bring your 2A delta D over and it'll be negative. VI squared is equal to negative 2. Now notice this time we do have to call down negative because on this side one's going up and one's going down. So it's going to be negative 9.81 meters per second squared times 1 meter. So positive 19.62, take the square root, 4.4294 meters per second, and that's up. So this one's up, this one's down. And that becomes important for the next question, because it wants to know if the tennis ball were in contact with the ground for 0.01 of a second, what's its acceleration? So the speed with which it reaches the ground becomes the initial speed that it hits the ground with. So this VF becomes the VI, and it was 4.8522 meters per second going down. And the speed with which it leaves the ground, for when we're looking at just the in contact with the ground part, it is the VF with which the contact with the ground happens, so 4.4294 meters per second. And it tells us it's in contact for 0.01 of a second, and it wants A. So we would just use A is equal to VF minus VI over delta T, where the VF is up, so it goes in as a positive, 4.4294 meters per second, minus the VI is down, so it goes in as negative 4.8522 meters per second, and then it gets divided by 0.01 of a second. Okay? And if you didn't round too much there, you get 298.16 meters per second squared, which is a huge acceleration. That little tennis ball is experiencing a lot of force in order to get itself turned around like that. And when we get to the next unit, we'll see that force and acceleration are connected. Okay? And it's probably a good thing that that's a tennis ball experiencing that and not you or I, because that could be fatal. All right, so those are all your homework questions. I'd like you now to go to one of the sheets I gave you yesterday, the one that's multiple step kinematics questions, because what we're about to begin now are ones that are a little bit tougher. And they're a little bit tougher because they're multiple step, kind of like this one that we just did is. Okay? And so I've given you 8 different example questions of multiple step ones. So today, if we were in class, I'd go through a few of these. And so that's what we're going to do on this video and the next video. Okay, so starting with example 1, objects traveling in a straight line but changing speed. So a car starts from rest, accelerates at a rate of 3 meters per second squared for 6 seconds. All right, and then it travels at this speed for 10 seconds, and then it slows down. So the first thing you do is you say, okay, how many parts are there to this question? So it's a car that's moving in a straight line motion, if you could imagine that's a straight line. And it starts from rest and speeds up. So the first section is speeding up. Then it says that it travels at this speed for 10 seconds. So this part is constant speed. And then it slows down. So then the last section is slowing down. Okay? So first figure out your parts, write the headings. Now the next key is separate your givens. So it starts from rest. So under speeding up, we know VI is 0. Accelerates at a rate of 3 meters per second squared. So A is 3 meters per second squared for 6 seconds. Delta T is 6 seconds. Then it says it travels at this speed. So now we're into the constant one. And so it's going to be a VAV. It travels at this speed. What speed is this speed? Well, it's the speed that it reached over here. We don't know what that is, but whatever it is, it becomes the VAV in the next section. So when we find it, we'll have our VAV. And it says it does this for 10 seconds. and then I'm going to run out of time.